This is lesson 10.1, graphing y equals ax squared plus c. You should be on page 628. Actually, this title is a little misleading. I'm not going to have you graph these. I'm going to have you sketch these. Now, there's a difference between graphing and sketching. Here's what sketching means. It means we're not using our calculator. You're not actually plotting points. Okay, we're not going to take graph paper. I'm not asking you to make this a mental math, make a table. You're not actually plotting points. You're just making a generalization of the graph. I'll show you examples of that in a minute. When you graph, you would use your calculator, you would make a table, you would plot the points. You can see an example of that here at the bottom where graph y equals 3x to the second power. You can see they took their calculator, they plugged this in the calculator, they made a table, and they just started plotting points. You can see them plotted here, and you just draw your curve. Okay? So we're not actually graphing. I mean, to graph it, you wouldn't have to know anything. You just plug it in your calculator, plot points, and create your curve. I'm going to have you sketch these. Now, a quadratic function is a nonlinear function. Now, let's think about that. Nonlinear means it's not straight. So a quadratic function is a non-straight function that can be written in the standard form y equals ax squared plus bx plus c, where a isn't 0. Now, this should look familiar to you because you've been factoring these back in the last chapter. Every quadratic has a U-shaped graph called a parabola. So when you look at these pictures, you'll notice you're always getting these U-shaped graphs. Those have a name. They're called a parabola. All quadratics create parabolas. In this lesson, you will sketch quadratic functions where b equals 0. So when you graph these, you'll see y equals ax squared plus c. b is going to equal 0 every time. So that's why you do not see a b value in the middle. When you have 0 there, it disappears. Let's talk about the parent quadratic function. The most basic quadratic function in the family of quadratics, called the parent quadratic, is y equals x squared. Now, that would be the same as y equals 1x squared plus 0. The line that passes through the vertex and divides the parabola into two symmetric parts is called the axis of symmetry. So in other words, there's an imaginary line that would divide my parabola in two equal parts. That imaginary line is called the axis of symmetry. When b equals 0, and remember, in this lesson, b is always going to equal 0. That means the axis of symmetry is at 0. The axis of symmetry is at x equals 0. And you can see I highlighted that here on the screen. Every problem today, since b equals 0, the axis of symmetry is 0. So that means the parabola will be situated or centered on the y-axis. The c value will always show you the y-intercept of your parabola. So if you notice, in this parent function, c is 0. So if you look at the graph, you notice how we have a point at 0, 0. That's the point where we have the y-intercept. Now that point has a special name in this problem, and I'll highlight this. The lowest or highest point on a parabola is called the vertex. Now you can notice here, that point is the low point. That point for this parabola would be called the vertex. So the vertex of this parabola is 0, 0. We're going to try sketching a few of these right now. So when we sketch these, We're going to sketch the function. We're going to compare the graph, or I should say compare the sketch. We're going to compare the sketch with the sketch of the parent function. And then we're going to write two sentences. When they say compare, it's always two sentences, just like prior units. We're going to compare the vertex, and we're also going to compare how the parabola opens. So let's sketch y equals negative 4x squared first. Okay, so we're going to sketch this. First of all, the parent function is y equals 1x squared plus 0. So there's my y-intercept at 0. And the number in front, 1, we're opening up, and there's a picture of the parent function. It's a parabola opening up. Now, I put some notes here for my actual function they wanted me to plot. I'll do this in black. The y-intercept for this is at 0, but now the value in front will always indicate if the parabola opens up or down. If it's positive, the parabola opens up. If it's negative, it opens down. So you notice this parabola is going to open down. And you see how this has a 4 versus a 1. It's going to open down, and it's going to stretch this out. It's opening 4 times more rapidly. Now, stretching a parabola out will make it narrower and thinner. So this is opening down, and it's narrower and thinner. I'll label my vertex of each at 0, 0. There would be a sketch. You notice I'm not using graph paper. I'm just sketching. Now, I need to write two sentences. Compare the vertex and compare how they open. So here are my sentences comparing. You notice I wrote two sentences. The first sentence, y equals negative 4x squared has the same vertex as the parent function. You can see that here, 0, 0. But y equals negative 4x squared is reflected and stretched. Reflected means opening down, and it's stretched out. It's opening 4 times faster compared to the parent function. That would be two sentences comparing the two. Let's do the next question. Y equals negative 1/3 x to the second power. All right, so the parent function, the y-intercept you can see here is 0, and it's opening up, and the parent function always looks the same. It has a vertex at 0, 0, and it's opening up. Now the second function, this has a y-intercept at 0 also. But this is opening upward, it's positive, but it's opening upward at 1/3 of the rate as the parent function. So 1/3, it means it's opening more slowly. 1/3 is quickly. So this is going to look more like this. It's going to be wider and opening more slowly. The vertex of each is 0, 0. Let me write two sentences comparing these two then. So the first sentence might be that y equals 1/3 x squared has the same vertex as the parent function. They both had a vertex at 0, 0. But y equals 1/3 x squared has a vertical shrink. Okay, remember it's opening more slowly. That's shrinking. Has a vertical shrink when compared to the parent function. Let's look at the third problem. Y equals x squared plus 2. I want to graph, or I should say sketch that and compare it to the parent function. And the parent function, the y-intercept is 0, and it's opening upward, and so the parent function always is going to look the same. It's there. Vertex is 0, 0. Now, this function, you notice the y-intercept is 2, so it's 2 units up, but it also has a 1 in front, so this is going to look exactly, I'm trying to make it look exactly like the parent function, except it opens 2 units up. Okay? So let me write two sentences comparing these now. And those sentences could be something like this. Y equals x squared plus 2 has a vertex of 0, 2, while the parent function has a vertex of 0, 0, which is called translating 2 units up. You can see 2 units higher. Y equals x squared plus 2 opens the same as the parent function. So I'm comparing their vertex, and I'm comparing how they open in two sentences. Let's try one more. Y equals 3x squared minus 6. I want to sketch. Now it says graph. We're going to always, when it says graph, we're going to sketch. So we're comparing sketches, not graphs. Okay? So let's go ahead and do this and compare it to the parent function. Okay, so we know the parent function, it opens up and it has a y-intercept of 0 opening up. So let's draw that first, just sketch it. So that might look like this. Okay, vertex is 0, 0. Now let's compare it to here. Now my actual function, the y-intercept's at negative 6. So I should move down 6, which might be about here. This is 0, negative 6. Now look at this number. This function is going to open 3 times more quickly than the parent function. That's going to make this narrower and rise faster. So maybe this might look like this. Narrower, rising faster. Oops. Let me try drawing that again. A little bit better. There we go. Okay. That might be a sketch of this. Now I want to write 2 sentences comparing the two. Let me do that. Okay, so one sentence should compare the vertex. Well, y equals 3x squared minus 6 has a vertex translated down 6 units from the parent function. You can see that here. The parent function's vertex was 0, 0. This is 0, negative 6. Now let's compare how they open. Y equals 3x squared minus 6 has a vertical stretch when compared to the parent function, because you notice this is opening 3 times faster than the parent function. On page 630 is a summary of all what I've talked about here. Okay? When you look at the a value in front, if a is bigger than 1, that's going to stretch the graph more than the parent function is stretched. It's going to be a thinner, narrower, rising faster sort of graph. However, if a is a number between 0 and 1, like I did a problem a couple of minutes ago that had a third in front, that's going to be a vertical shrink. It's going to be a wider graph opening more slowly. If a is a negative amount, less than negative 1, it's going to be a vertical stretch with a reflection. That happened on the very last problem I showed you. Okay? Well, I shouldn't say the very last problem, the very first problem where we had the negative 4x squared. I stretched the graph and it was reflected. It was rising 4 times more quickly, but it was reflected because we had the negative. If a is something between negative 1 and 0, we would have a shrink and a reflection. And then let's talk about the c value. If c is greater than 1, we're going to have an upward vertical translation. However, if c is less than 1, like in the last problem where we had 3x squared minus 6, that minus 6, that's less than 0. If c is less than 0, that means I will have a downward vertical translation. In our last example, right here, we translated our vertex 6 units down, a downward vertical translation. Generally speaking, the word problems, you're going to have to use a graph. Well, if you have to use a graph, I have to let you use your calculator. The word problems typically are calculator questions. Here would be a good question that would be a non-calculator type thing. Describe how the graph of the function y equals x squared plus 2 would be affected if the function were changed to y equals x squared minus 2. Well, think about it. Y equals x squared plus 2 would have a vertex 2 units up and be opening up. But y equals x squared minus 2 would have a vertex 2 units down, but it would be opening up in the same way. Can you see how this translated 4 units down? That would be the answer to this. How would it be affected? It would move the vertex 4 units down if we change from positive 2 to negative 2. I'm going to pause the video there. If you have questions, make sure you ask during class.